Okay, operations with complex numbers. Right, so we actually have quite a few examples that we're going to do today, but most of this is review of things we've done in the past, so it really shouldn't be too bad then. Just as you can represent real numbers graphically as points on a number line, you can also do that with complex numbers in a special coordinate plane. The complex plane is a set of coordinate axes in which the horizontal axis represents real numbers and the vertical axis represents imaginary numbers. So you can see where here's the real axis, and then we have the imaginary axis is actually the y-axis. So when we graph complex numbers, we graph them exactly like we would a regular coordinate point, where the value of A is our real part, and the value of B is the imaginary part. So basically, I'm going to plot the point, if I have A plus BI is my complex number, I'm basically going to plot the point A comma B, right? Where A is our real part and B is the imaginary part. Spencer, put your phone away. So to be able to plot these then, right, if I want to graph 2 minus 3i, I'll go to the right 2 and down 3. 2, negative 3. So that's 2 minus 3i there. For letter B, negative 1 plus 4i. So we're going to go to the left 1 and up 4. Yep. 4 plus I. The value of A then is 4. The value of B is 1. And for negative I, where's that going to be at? Okay. To the left or down? Down. Okay. So when you're graphing complex numbers, first of all, you make sure that it's in the form A plus BI. You go left to right, the value of A, and up or down, the value of B. Now that we know where those points go, one of the things we want to find is how far is that point from the origin, okay, or from our starting spot. So we're going to talk about absolute value. Well, the absolute value of a complex number is the distance it is from the origin. Okay? The absolute value of a complex number is the distance it is from the origin. What does this thing here, square root of a squared plus b squared, remind you of? Something that we've used quite a bit in math. Not necessarily so much in here, but in there. How about, what if I wrote it like this? Does that remind you of anything? Okay. How about the quadratic formula? Or not the quadratic formula, Pythagorean theorem, sorry. Okay, here's the Pythagorean theorem, okay, which is used when we're working with the sides of a right triangle. So basically, when we're trying to find the distance from the point to the origin, we're going to use the Pythagorean theorem to find that. So the absolute value of a complex number, so make sure you write this down. Okay, here's the formula. Absolute value of a complex number. So the absolute value of a plus bi equals the square root of a squared plus b squared. It's basically just the Pythagorean theorem. So you take the complex number, you identify the values of a and b, and then plug them in. It's not just, the absolute value of whatever you have there, which is what a lot of people do. You have to use this formula. So here they want us to find the absolute value of these three complex numbers. And we have two steps from that. First thing we should do is determine the values of a and b. And then So we might want to rewrite the problem first so that it's in the form a plus bi, and then put those values into the formula. So for letter A, what's the value of A? What's the value of B? Okay. All right, A is 3, B is 5. So then to find that absolute value, we just do the square root of 3 squared plus 5 squared. So 9 plus 25 is 34. Their complex numbers are all in the form a plus bi. A is the real part, B is the imaginary part. Okay. Yep. All right, letter B. What are the values of A and B for the square root of negative 13? What's A? Okay, and B is 0. All right, now do I need to do any real work for that then? No. Chris, what's the answer? What's the absolute value of any number? Okay. All right. Well, maybe your friend Chris can help you. Okay. This is 13. Okay. Now, and I want you to, and you have to remember that if it's in the form a plus bi, you've got to use this formula. Okay. Square root of a squared plus b squared. So if I did that here, we would get negative 13 squared plus 0 squared, which is just the square root of negative 30. Doggone it, come on. Square root of 169. Okay? And the square root of 169 is 13. But now if you think about it, where's that on the graph? Negative 13 is where? If I graph that complex number, where would it be at? Okay. It would just be, do I go left, right, up, or down 13 then? For this one. Okay, we go left 13. So that complex number is over here. Well, how far is negative 13 from the origin? 13. Okay. The big 1, 3, that's right. So in that case, I wouldn't need to use the formula because I know that that's 13 units from 0. Okay? Yeah, for letter C, where's negative 7i at on the graph? Okay, it's down here, right? Oops. Down here at negative 7i. How far is that from the origin? 7. So this answer here is 7. Okay. But anytime it's in the form a plus bi, if you have values for a and b, you've got to use the formula square root of a squared plus b squared to find the absolute value. Okay, adding and subtracting complex numbers. Okay. You guys have added and subtracted polynomials, right? 4x plus 3 plus 3x plus 7. You guys have done lots of them, okay? That's all this is. If you're adding and subtracting with complex numbers, we just use the same rules we would as if it was an x there. So if we're adding, we drop the parentheses and add the like terms. Okay. So if you're adding, just drop the parentheses, add the like terms. So 4 minus 6, negative 2. 2i minus 7i is negative 5i. That's all you do. Just like you've done many, many times before. That's the answer. There's nothing else to figure out. You can't do anything more than that. Okay? What about when it's subtracting? What do we do? Similar, but we have to get rid of the minus sign, right?
You put a plus on it, put a plus to it.
Okay? So you can think of this two different ways. Okay? One is when I drop the parentheses, I change the signs, or you can think of it as distributing the negative. So if I distribute the negative, that means this minus 2 is going to become a plus 2, and this negative 3i is going to be a positive 3i. Is there a negative in front of this? No. Okay? All right. 5 plus 2 is 7. Negative 2i plus 3i is plus I. Okay? So when you are adding or subtracting complex numbers, we do it just like we would any other time. For adding, just drop the parentheses and add. Subtracting, change the signs. Okay, drop the parentheses, change the signs, and combine them. Okay, multiplying. All right, when we multiply complex numbers, I have a little note up here. It says, in the book, I think we just went from example 3 over to example 5. And so for example 4, they tell you to use geometry to multiply or to add and subtract. And you don't need to do that, okay? Just add and subtract them just like we just did, okay? So if it says specifically use geometry, you don't need to do that, okay? Now, we're multiplying, okay? One thing that we need to remember is that I squared equals negative 1. And so we're going to end up with I squared in some of these problems. So when we multiply complex numbers, we multiply them just like we would polynomials. No different. So if I have a negative 2i in front of this 2 minus 4i, what do? Okay, we're just going to distribute. Okay. What's negative 2i times 2? Okay, negative 4i. And negative 2i times negative 4i. Okay, plus 8i squared. Okay, now, one of the things that we learned back in, I think, like lesson 5, okay, is that I squared equals negative 1. Okay, well, if I squared equals negative 1, then I have to replace this I squared with negative 1. So then we get negative 8 minus 4i. And we always have to write it in the form a plus bi. Right? So the real part goes first, the imaginary part goes last. So this multiplication is just like the multiplication you've done before. If it's just a monomial times a binomial, we just distribute. If we have two binomials like we hear in letter B, then we're going to do what? FOIL them. Okay? And the only difference is just like we had the situation up here, is that if we have I squared, we're going to change that to negative 1. All right, so we FOIL. 3 times 4 is 12. 3 times negative I is negative 3i. 6i times 4 is 24i. And 6i times negative I is negative 6i squared. So if I rewrite it, as, now, this I squared is negative 1, right? Okay, what's negative 6 times negative 1? Okay, positive 6. Okay, so we're going to write it. So we write our real part first, and then the imaginary part. 12 plus 6 is 18. Negative 3 plus 24 is plus 21i. Okay. So that's, like I said, with this lesson, most of it is stuff that we've done before. We're just putting the I in there. So all this multiplication is similar to what we've done before. You just have to remember to change. Ooh, change your I squared to negative 1. Okay. You just got to remember to do that. Okay. All right. Let's look at this last one we got here. Oh, nope, I got 2 more, I guess. Okay. Okay. Well, how about you do this one? Okay, you guys do letter C. And letter D. You guys do C and D. All right. Claire, what did you get for C?
Minus 81I.
2 minus 81I. Okay, get somebody get something different than that? You got 85. Okay. How many people got 85? Okay, a couple people did. All right, so let's see what happens when we FOIL this. Right. So we get 4 and minus 18I and plus 18I. Oh, that's nice, isn't it? Okay, that makes 0. And if I multiply these, I get negative 81I squared, right? Okay. And if I squared is negative 1, that makes this equal to positive 81. Yep, so this is going to be 4 plus 81, which is 85. Okay, right. Now, here's the thing. This is the difference of 2 squares, right? Remember difference of 2 squares? A squared minus B squared equals A plus B times A minus B. Right? So we actually have the difference of 2 squares there. And so what happens in that situation is that when they multiply them, we get rid of the I. Just like we did with the radicals at one time, we got rid of the radical. And so these are actually conjugates of each other also. Remember? The I part changed signs. So the nice thing about that is it eliminates the I. And we're going to use that when we get to the very last example. All right? So at least what did you get for D? And this does equal 30. Okay? We get negative 5 times 6 is negative 30. I squared. I squared is negative 1, so that's going to be positive 30. Good. Raising I to a power. Okay. First of all, we know that I to the first power is I, isn't it? Yeah, that makes sense. And we've learned that I squared equals negative 1. Well, what happens if I want to get like I to the 14th or I to the 85th or I to the 292nd? Okay. Well, we can find that out by using the powers of I. Okay. So let's look at I cubed. I cubed would be equal to I squared times I. Right? Wouldn't I cubed be I squared times I? Okay. What's I squared equal? Negative 1. So this is negative 1 times I, which is just negative I, right? Yes? Okay. Okay. So I to the 4th. I to the 4th, I could say that's I squared times I squared, couldn't I? Okay. Because 2 plus 2 is 4. Okay. So that means we have negative 1 times negative 1. Well, what's negative 1 times negative 1? 1. All right. I to the 5th. I to the 5th is I to the 4th times I. Right? Okay. What's I to the 4th? 1. So 1 times I equals I. That's pretty handy, isn't it? How about I to the 6th then? How could I break up I to the 6th? Okay, I could do I to the 5 times I. Is there another way I could do it? 4 and 2. Okay. I to the 4th times I squared. Now, why is 4 so nice, Jordan? Yeah, because it's 1. And 1 times anything is that whatever, right? So this is 1 times negative 1, which is negative 1. Okay. All right, I to the 7th. I to the 7th would be I to the 4th again times I cubed. All right. So I to the 4th is 1. I cubed is negative I. 1 times negative I is negative I. I to the 8th. How could we break up I to the 8th? 4 and 4. I to the 4th times I to the 4th is equal to 1, because 1 times 1 is 1. Okay. Anybody see a pattern? No? Okay. All right, so let's look at, let's go on. I to the 9th. How could I break up I to the 9th? 8 and 1, right? Okay. Well, I to the 8th is 1. I to the 1st is I. Well, what's 1 times I? I. How about I to the 10th? Well, 9 and 1 would be nice, but how about, what's nice about, oh, yeah, we could do 8 and 2. If I do 8 and 2, we have 1 times negative 1, which is negative 1. Okay. 11. 8 and 3, right? Okay. 1 times negative I is negative I. Right. 12. How about 12? 4, 4, and 4, right? Okay, or 8 and 4. And that's equal to 1. Okay. All right. So that's a nice little pattern, isn't it? Okay. Well, you may think so, but that's okay. It's like confusing. Okay. But here's the thing is that what do I know about 4, 8, and 12? Okay, they're all 1, but they're also what? Multiples of 4. And so any multiple of 4 is going to be equal to 1.
Okay. And then 3, 7, and 11 are all negative I. And then 2.
So 1 less than 4 would be negative I. And 2 less than 4 would be negative 1. And 1 more than 4 would be I. Okay. Okay. So I to the 14th. Okay, let's ignore the negative 6 for the moment. Let's look at I to the 14th. Okay. I to the 14th. Okay. What's the multiple of 4 less than 14? Okay. Multiples of 4, okay, that takes me to 14. So if I go, I got 4, 8, 12, and then 16 is the next one, right? So this would be, you're right, Elise. So this would be I to the 12th times I squared. I want this number here to be a multiple of 4. Okay? Because then whatever's left is either going to be 1, 2, or 3. Okay? And we know the I squared is negative 1. So this would be negative 6 times negative 1, which is 6. Okay? I to the 63. I to some number to the 4th, or some multiple of 4 times I to some number less than 4. So let's see. If you have to, you can count. 4, 8, 12, 16, 20, 24. You can do that if you wanted to. Or 63, what's the multiple of 4 closest to 63? Well, it must be an even number, right? Is 62 a multiple of 4?
No.
No. Is 60 a multiple of 4?
Yes.
Yes, it is. So I could make this I to the 60th and I to the 3rd. And I to the 3rd is? Negative I. Okay. So we want a multiple of 4 and the remainder. Okay? All right. So if I took 63 and divided it by 4, I would get 15 with a remainder of 3, right? And this remainder of 3 is the number I'm looking for, because that would tell me that it's negative I. Okay. If you recall, when we were dividing with radicals, we said that you cannot have a radical where at? In the denominator, okay? The same thing is with complex numbers. We cannot have a complex number in the denominator, so you can't have I in the denominator, all right? So we talked about the complex conjugate, and so we need the complex conjugate to get I out of the denominator, just like when we did this multiplication over here. When we multiplied by the complex conjugate, what happened? Our answer did not have an I in it, we just had 85. And so to get the I out of the denominator, we're going to multiply by the complex conjugate. And then I'm going to show you a little trick with your calculator. So, what's the conjugate of 5i? Now remember, when we talk about conjugates, if I have a plus bi, the conjugate would be a minus bi. So what's the conjugate of 5i? Negative 5i. So that means I'm going to multiply the numerator and the denominator by negative 5i. Just like if this said the square root of 3 here, we would multiply numerator and denominator by square root of 3 to get it out of there. Okay. Because this is 0 plus 5i, right? That's that complex number. So the conjugate would be 0 minus 5i, or just negative 5i. So then we multiply. And then simplify. So we have positive 50 minus 15i over positive 25. Now, when you do these, then you have to pull it apart, okay? Because it has to be an a plus bi form. So when we pull it apart, that means we're going to have 50 over 25 minus 15 over 25i. And then reduce the fractions. Okay, 50 over 25 is 2. 15 over 25 is 3/5. So we're multiplying by the conjugate. Okay, multiplying by the conjugate. Okay, take your calculator. I'm going to show you how to do letter B the easy way. Okay. You guys all know how to use your calculator to divide, right? Okay. How do you use your calculator to divide? Okay. Well, what if I have 2 things in the numerator and 2 things in the denominator? What do I have to do? You have to use parentheses. Okay. So these calculators are so amazing. Oh, wait a minute. Is there an I on your calculator?
Yep.
Where at? Oh, second decimal point. Look at that. Divided by 4 minus 2i. Now, the only thing is, can I leave that as my answer? No. Why not, Jordan? It needs to be in a fraction. So how can I change that to a fraction? Math and fraction. Oh, look at that. Okay. So when they're asking you to divide, I'm giving you a easy way to do them using your calculator. They are amazing.